Good morning, all of you. In this session, I'm going to explain about simple problems on shaft keys. In previous class, already we discussed about different types of keys used for shafts. In this session, I'm going to explain about a problem on rectangular sunk keys and square sunk keys. This is a rectangular sunk key. Here capital D is the diameter of the shaft. So the size of the key always depends upon the diameter of the shaft. Okay. And here W is the width of the key. W equal D by 4 and T is the thickness of the key. Okay. So this is the cross-sectional view. This is a side view of this rectangular sunk key. Okay, this is the width and this one is thickness. Okay. And this one is the front view. Here you can observe in front view, you can observe the length of the key. The length of the key always depends upon the size of the coupling or hub. Here, the bottom surface has no taper, but we have to provide a taper in 1:100 for a top surface. Now this is a square sunk key. Here the cross section is square. Okay, in this square sunk is width of key equal to thickness of the key. Okay. In square sunk key also you have to provide a taper 1:100 for a top surface only. Now this is a parallel sunk key. Parallel sunk key may be rectangular or square cross section. Okay. Here there is no taper for top surface. Okay, don't provide any taper. Now for design of sunk keys, you have to know the fundamentals about the forces acting on the key. When a key is used in transmitting torque from a shaft to a rotor or hub, the following two types of forces act on the key. First force F1 due to fit of the key in its keyway. As in a tight fitting straight key or in a tapered key driven in place, these forces produce compressive stresses in the key, which are difficult to determine in magnitude. And another force is F due to the torque transmitted by the shaft. These forces produce shearing and compressive stresses, shearing and compressive stresses in the key. Let's consider a shaft and a keyway and a key. Okay, this is the front view of the key and shaft. Here, this is the side view of shaft with the key. Okay, here you can observe this one is a key, cross section of a key. Okay, here F1 is the force. Okay, and F is the shearing force, shearing or compressive force. Okay. The forces acting on key for a clockwise torque being transmitted from a shaft to a hub are shown in figure. In designing a key, forces due to fit of the key are neglected, and it is assumed that the distribution of forces along the length of the key is uniform. For estimate the strength of a key, you have to consider shearing and crushing. For design of sunk keys, you have to consider shearing forces and crushing forces. Okay. Here, let capital D is the torque transmitted by the shaft. Okay. And also torque transmitted by shaft equal to torque transmitted by key. F is the tangential force acting on the circumference of the shaft. Small d is the diameter of the shaft. and L is the length of the key. Small L is the length of the key, W is the width of the key, and T is the thickness of the key. Okay. Here tau is the shear stress induced in the key material. Sigma C is the crushing or compressive forces or compressive stresses induced in the key material. Here F is the force. Okay, tangential force acting on the key. Okay, here F is the tangential force acting on the key. For determining the tangential force, you have to multiply resisting area, shearing area. Okay, shearing area with respect to shearing stresses. So here L into W is the shearing area. Okay, L into W is the shearing area and tau is the shear stress. So from this equation, L into W into tau is the shear force. Now, if you want to determine the torque transmitted by the key, you have to multiply this shearing force with respect to radius of the shaft. Here capital D is the diameter, so the radius of shaft is equal to D by 2. Okay, torque equal to torque transmitted by key equal to shear force acting on key into radius of a shaft. Okay, here F equal to L into W into tau and D by 2. So this is the formula for torque transmitted by the key. Okay, here this formula is used for shearing strength. Okay, for determining the shearing strength. In similar way, if you want to design a key on the basis of crushing strength, then you have to use this formula. Okay, the crushing force or compressive force acting on the key. Compressive force acting on the key, F equal to compressing or crushing area into crushing stress. Crushing stress also known as compressive stress. So sigma C is the compressive stress or crushing stress. Resisting area for crushing or compressive forces resisting area is L into T by 2. Okay. After that, you have to use a torque formula. Torque equal to force into radius of the shaft. Here the force is L into T by 2 into sigma C into D by 2. So this is the formula for torque on the basis of design on the basis of compressive forces. Okay. Now these are the important formulas used for design of keys. For determining the power transmitted by the shaft, you have to use this formula. Power P equal to T into omega. Omega is 2 pi n by 60. Okay, omega is the angular velocity. So from this equation, first of all, you have to determine the value of torque transmitted by the shaft. T equal to 60 into P by 2 pi n. This is the formula for torque transmitted by the shaft. Okay. After getting the value of torque, you have to determine the suitable diameter of the shaft. Okay. Torque T equal to pi d cube by 16 into tau. Okay. You have to substitute the value of T value in this equation. Okay. After substituting, you can get the value of diameter of the shaft D. Okay. For solid shaft. Okay. And also you can use this formula for determining the diameter of the shaft. Here L is the length of the key and W is the width of the key. T is the thickness of key. For rectangular key, you have to use width W equal to D by 4 and thickness equal to D by 6. Okay. For design of sunk case, in first case you have to consider shearing strength. Okay. Shearing strength. That means you have to consider shear stress. This is the formula for shearing strength of the key. Torque transmitted by the key equal to L into length of the key into width of the key into shear stress induced in the key into radius of the shaft. Okay, by using this formula, you can determine the shear stress induced in the key material. Okay, from this equation, you can determine the value of shear stress induced in the key material. Okay. If you want to design a key on the basis of crushing stresses, then you have to use this formula T equal to L into T by 2 into sigma c into D by 2. Length of the key into thickness of half of the thickness of key into compressive stresses induced in the key material into radius of the shaft. From this equation, you can determine the value of compressive stresses induced in the key material. Okay, these all are the important formulas used for design of keys. Okay, design of sunk keys. This is a problem, example problem. Okay, this is a question. The question is design the rectangular key for a shaft of 40 mm diameter. The shearing and crushing stresses for the key material are 42 megapascal and 70 megapascal. Okay, this is a given question. From the given question, first of all, you have to identify the given values. Okay, here the diameter of the shaft is given. Okay, diameter D equal to 40 mm. Shear stress and compressive stresses also given. Shear stress equal to 42 megapascal and crushing or compressive stresses equal to 70 megapascal. Here tau equal to shear stress 42 megapascal, 1 megapascal equal to 1 Newton per mm square, and sigma c is the compressive stress equal to 70 megapascal, 1 megapascal equal to 1 Newton per mm square. Now, first of all, you have to determine the value of torque transmitted by the shaft. Here the diameter of the shaft is given. So this is a solid shaft. Already we know that from torsional equation, the torque transmitted by the shaft, solid shaft, T equal to torque transmitted by the solid shaft, T equal to pi d cube by 16 tau. Okay, this is the formula for torque transmitted by the solid shaft only. Okay, here capital D is the diameter of the shaft, tau is the shear stress induced in the key material or shaft material. Okay, here you have to substitute the value of tau in this equation. You can get the value of torque. Torque T equal to 55,27,787.56 Newton mm. After getting the torque value, you have to determine the suitable size of key, that is the width and thickness of the key. Already we know that the width of the key for a rectangular key, the width of the key equal to diameter by 4, diameter of the shaft divided by 4. So you have to substitute the value of diameter 40 mm divided by 4. So the width of the key equal to 10 mm. In similar way, the thickness of the key T equal to D by 6, D equal to 40 mm. Okay, so the thickness of the key T equal to 40 by 6 equal to 6.66 mm, nearly 7 mm. Okay, width of the key equal 10 mm and thickness of the key equal 7 mm. After that, you have to determine the suitable length of the key for bearing these two stresses. Okay, you have to check these two dimensions, width and thickness. Okay, for checking these two dimensions, you have to consider shearing strength. Okay, now you have to consider shearing strength of the key. Here, this is the formula for shearing strength of the key. Torque T, torque transmitted by the key equal to torque transmitted by shaft. Okay, that value equal to length of the key and width of the key and shear stress induced in the key into radius of a shaft. Okay, in this equation, you have to substitute the value of width. Okay, width, shear stress, and diameter and torque value. Okay, from this equation, you can get the value of length of the key. Okay, from this equation, the length of the key, the required length of the key L equal to 62.83 mm. That one also equal to nearly equal to 63 mm. Okay, so this is the length of the key on the basis of shearing strength. Okay, and also you have to determine the length of the key. Okay, considering the compressive stresses. On the basis of compressive strength, you have to determine the value of length of the key. This is the formula for torque transmitted by the key on the basis of compressive stresses. Okay, in this equation, you have to substitute the value of torque, length of the torque and thickness of the key, compressive stresses, and the diameter of the shaft. From this equation, you can get the value of length of the key. Here, on the basis of compressive strength or crushing strength, the required length of the key equal to 108 mm. Okay, from these two answers, you have to take larger value. Taking larger value. Okay, so the required length of the key is 108 mm. Okay, so this is the answer for this problem. This is the diagram of a key. Okay, here this is the width. Okay, this is the width, and this one is thickness of the key. Okay, and this one is the length of a key. Okay, these are the dimensions of a rectangular key. From this problem, the required width is 10 mm and thickness is 7 mm, and the required length is 108 mm. Taking larger of these two values. Okay, now coming to the another example problem. A 40 mm diameter shaft is subjected to a tangential force of 30 kilonewtons around its circumference. Determine the sizes of the key. Take shear stress tau equal to 42 megapascal. Okay, here the diameter of the shaft is given. Okay, the diameter of the shaft is 40 mm, and here the tangential force is given. Okay, tangential force, that means shear force. Okay, from given data, diameter of the shaft capital D equal 40 mm, and here tangential force or shear force. Tangential force or shear force equal to F. F equal to 30 kilonewtons. 1 kilo equal to 1000. So 30,000 newtons is the shear force. Shear force or tangential force. Okay. Here tau is the shear stress. Okay. Shear stress tau equal to 42 megapascal. 1 megapascal equal to 1 Newton per mm square. Okay. From these three values, you have to determine the suitable dimension of the key. Okay, so this is the formula for torque. Torque transmitted by the solid shaft. Torque equal pi d cube by 16 into tau. Okay, this one also another formula for torque transmitted by the shaft. Here in this equation, you can observe the diameter of the shaft and the shear stress induced in the key material also given. Okay, you can use this formula or this formula for determine the value of torque. But in our question, shear force equal to 30 newtons is given. So you have to substitute this shear force. F is the shear force. So you have to substitute this 30 kilonewtons value in this equation for getting the torque. Okay. Here the width of the key equal to diameter by 4. Okay, here the diameter of the shaft equal to 40 by 4 equal to 10 mm, and thickness of the key T equal to D by 6. Okay, that value equal to 7 mm. Okay, these two are the cross-sectional dimensions. After that, you have to determine the suitable length of the key. L is the length of the key. Okay, the length of the key is obtained by considering the key in shearing and crushing. But here the crushing stress is not given. So you have to design a key on the basis of shear stress only. Okay, this is the formula for torque transmitted by the key on the basis of shearing strength. Okay, so here T is the torque transmitted by the shaft, and L is the length of the key, W is the width of the key, tau is the shear stress, and D by 2 is the radius of the shaft. So here you have to substitute the torque formula in this equation. Here the torque T equal to F into D by 2. F is the shear force. So first of all, you have to determine this value. After that, you have to substitute this value in this equation for determine the suitable length of the key. Okay. Here F is equal to shear force equal to 30,000 newtons. D equal to 40 divided by 2. L is the length. You have to determine that value. And here W is the width of the key. W equal to 10 mm. And shear stress tau equal to 42 megapascal. And D equal to 40 mm. Okay. From this equation, the length of the key L equal to 71.42 mm. Okay. So 72 mm, nearly 72 mm is the required length of the key. Okay. So this is the answer for this problem. This is the cross section or isometric view of a key. Now coming to the another example problem. Shaft of 60 mm diameter is transmitting 200 kilowatts at 2400 rpm. A square key having 18 mm side and 90 mm long for the shaft. Determine the induced shear stress and compressive stresses in the key. Okay, in given question, first of all, you have to identify the given values. Here, the diameter of the shaft is 60 mm, and the power transmitted by the shaft also given. Power transmitted by the shaft equal to power transmitted by key. Okay, that value equal to power P equal to 200 kilowatts. Okay, 200 kilowatts is the power transmitted by the shaft. And here this one is the speed of the shaft. Okay, that one is N. Okay, here the key is having a square cross section. So here these are the dimensions of the key. Okay, here 18 mm and 90 mm. 18 mm is the width, 90 mm is the long. That means length. Length of the key is equal to 90 mm. Width of the key W equal to 18 mm. Okay, thickness is not given. Determine the induced shear stress and compressive stresses in the key. Okay. Here, this one is a square key. So for a square key, width and thickness both are equal. Okay. For a square key, you have to consider width and thickness both are equal. Okay. So here the diameter of the shaft D equals 60 mm and the speed of the shaft equal 2400 rpm revolutions per minute. Here the shear stress is not given, you have to determine that value, and compressive stress also you have to determine. And here the power is given, power transmitted by the shaft P equal to 200 kilowatts. 1 kilo equal to 1000, so 2 lakhs. Okay, the power P equal to 2 lakhs watts. 1 watt equal to Newton meter per second. Okay, 1 watt equal to Newton meter per second or joule per second. Okay. Already we know that power transmitted by a solid shaft or hollow shaft, power P equal to torque into angular velocity. Okay, here angular velocity equal to 2 pi n by 60. Okay, P is the power. Here the value of power is given and the speed of the shaft n also we know that. From this equation, you can get the value of torque transmitted by the solid shaft. Okay, torque, mean torque T equal to 60 into P by 2 pi n. From this equation, the torque transmitted by the shaft T equal to 795.775 Newton meter. Okay, here the power is in meters, so the torque also in meters. So torque T equals 795.775 Newton meter. Okay, force into distance. That value equal to, you have to convert this value into mm in millimeters. Okay, you have to convert this value into millimeters. So 1 meter equal to 1000 mm. So 795.775 into 10 power 3 Newton mm. This is the torque transmitted by the shaft. After that, from given question, the width, the given cross section is a square. So width and thickness both are equal. So width equal to 18 mm So thickness also 18 mm. And the length of the key equal to 90 mm. Okay, length of the key equal to 90 mm from given question. Okay, after that you have to determine the induced stresses, induced shear stress and compressive stresses in the key. For determining the shear stresses induced in the key, you have to use a formula torque T equal to L into W into tau into D by 2. Okay, design of key on the basis of shearing strength. Okay, from this formula you can calculate the value of shear stress induced in the key. Now you have to substitute the value of torque T and length, width and diameter. Okay, so after substituting the values, you can get the value of shear stress induced in the key. Okay, here torque T in millimeters, length also in millimeters. Okay, W also width in millimeters, diameter also in millimeters. Okay, from this equation, torque shear stress induced in the key tau equal to 16.37 Newton per mm square. Okay, so this is the answer for this problem. After that, you have to determine the value of compressive stress or crushing stress induced in the key. For determining the compressive stress induced in the key, you have to use this equation. From this equation, you can get the value of crushing stress or compressive stress induced in the key material. Okay, now you have to substitute the value of torque, length, thickness, and diameter of the shaft. You can get the value of compressive stress. From this equation, the compressive stress or crushing stress induced in the key material is sigma c equal to 32.74 Newton per mm square. Okay, so this is the another answer for this problem. Okay, so here the width of the key equal to 18 mm, thickness of the key equal to 18 mm, and length of the key equal to 90 mm. Okay, you have to use these three values to determine the suitable stresses, to determine permissible stresses induced in the key material. Okay, tau is the shear stress induced in the key material, and sigma c is the compressive stresses induced in the key material. Okay, so this is a square key. Okay, here the width and thickness both are equal. Okay, this is a last problem in this session. Okay, it is very important problem for exam point of view. The question is a 40 mm diameter shaft is made of steel with a yield strength of 400 megapascal and a parallel key of size 14 mm wide and 9 mm thick made of steel with a yield strength of 340 megapascal is to be used. Find the required length of key if the shaft is loaded to transmit the maximum permissible torque. Use the maximum shear stress theory and assume a factor of safety of 2. From given question, the diameter of the shaft D equal to 45 mm and width W equal to 14 mm. Okay, width of the key, parallel key equal to 14 mm and thickness of the key equal to 9 mm. Okay, and here you can observe the yield strength, tensile yield strength is given, that is 340. Okay, yield strength of the key material sigma yt equal to 340 megapascal, 1 megapascal 1 Newton per mm square, and here sigma yt for a shaft 400 megapascal, sigma yt for shaft equal 400 megapascal. Here the FS factor of safety is 2. L is the length of the key. You have to determine that value. According to maximum shear stress theory, maximum shear stress for shaft tau max equal to yield stress divided by 2 into factor of safety. Okay. From this equation, you can get the value of length of the key. This is the shape of a key. Now, from this equation, tau max maximum shear stress induced in the shaft material, tau max equal to sigma yt by 2 into fs. Sigma yt is the shear yield stress for shaft material, equal to 400 megapascal divided by 2 into 2. fs is the factor of safety for shaft material. So the maximum shear stress induced in the shaft material, tau max equal to 100 megapascal, and the maximum shear stress induced in the key material equal to tau k. Suffix k refers key. Okay, tau k equal to yield stress for key material divided by 2 into factor of safety of a key. 340 is the yield strength of a key. Okay, 340 divided by 2 into 2. Okay, here from given data, fs equal to 2, factor of safety equal to 2. Okay, so the shear stress induced in the key material equal to 85 Newton per mm square. Okay, already we know that from maximum, sorry, from torsional equation, torque transmitted by the solid shaft T equal to pi d cube by 16 into tau. Okay, this is the formula for a torque transmitted by solid shaft. Okay, in this equation you can substitute the value of tau max for shaft material. Okay, d is the diameter of the shaft. Okay, from this equation, the torque transmitted by the shaft equal to 1.8 into 10 power 6 Newton mm. After getting the torque value, you can get the value of length by using this equation. Torque transmitted by the shaft, sorry, torque transmitted by the shaft equal to torque transmitted by key. Okay, so torque transmitted by shaft equal to torque transmitted by key. So this is the formula for a torque for key material on the basis of shearing strength. Design of key on the basis of shearing strength. Torque T equal to L into W into tau K into D by 2. Okay. In this equation, you can substitute the value of width and shear stress induced in the key material and the diameter of the shaft and the torque. Okay. From this equation, the length of the key is 67.2 mm. Okay. So on the basis of shearing strength, the required length of the key equal to 67.2 mm. Okay. In similar way, you have to determine the length of the key on the basis of crushing strength. Okay. So here this one is the torque induced in the key material equal to length of the key into thickness of the key into crushing stress induced in the key material into diameter by 2. Okay. Now you have to substitute the values of torque, thickness, and crushing stress, and diameter in this equation. You can get the value of length of the key on the basis of crushing strength. Okay. So from this equation, the required length of the key on the basis of crushing strength equal to 104.6 mm. Okay. Here this one also length of the key. This one also length of the key. From these two values, you have to select larger value. Okay. Taking larger of two values. Okay. From these two values, the larger value is 104.6 mm. So the required length of the key is 105 mm. Okay, so this is the final answer for this problem. Okay, in next class I will explain about design of shaft on the basis of torque, Okay.